And one other thing about spin, we said it's not just the electron that has spin angular momentum, right? The nucleus itself could have a spin angular momentum. In the case of a proton, for example, the spin quantum number for a proton is 1/2. In fact, that's the basis for your NMR spectroscopy in organic chemistry. When you're looking at the spin of the proton NMR. So interaction of the electron spin with the nuclear spin, okay, can add one further correction to your Hamiltonian. That adds another extra term in your, what do you call it, potential energy in your Hamiltonian. Okay. Since your electron in the 1s orbital can be spin up or spin down, the nucleus, what's the spin quantum number for a proton? Also 1/2. So your proton we can say is also spin up or spin down. Okay. So if your electron spin and your nuclear spin are parallel, it turns out you get a higher energy state. Okay. That adds to your potential energy. But if your electron spin and your nuclear spin are anti-parallel, that gives you a lower energy. So that's for the splitting of the. So the splitting of the 1s level in your of your hydrogen atom. Okay. It's not due to spin-orbit interaction. There isn't any, right? There's no orbital angular momentum for the electron. But under very high resolution, look at the spectrum. There's still a splitting there. And so that transition between those two states would correspond to a wavelength of around 21 centimeters. Okay, that's a very long wavelength. So very long wavelength means what in terms of in terms of frequency? High frequency or low frequency? That's going to be very low frequency, right? And so that's going to be very hard to detect. But you can, so that splitting, the gap between those two energy levels are very small. But you can, if you're interested in learning more about that, you can just do a search for the 21 centimeter line of hydrogen. Okay. And what's the main? So if you go to that Georgia State website, again, you can find that. Did I start the broadcast? I did. Okay. So you're looking at a splitting of 5.9 times 10 to the negative 6. Okay. So wait a minute. That's very long wavelength, so very low frequency. 1420 megahertz. Okay. So here you have when the spins are anti-parallel, you have a lower energy as opposed to when the nuclear spin and the electron spin are parallel. Okay. So this is what they use to map the hydrogen in the galaxy.